radiation, conduction and convection questions. Question 1, you're shown a diagram of a vacuum flask and asked what forms of heat transfer does the vacuum reduce and why. The answer to that is it reduces conduction and convection heat transfer, because there's no air in the vacuum. It can't, the air can't move around and convect heat in the same way that because it's not touching anything, it can't conduct the heat either to the air or to other materials that are touching it. The second part of that, what forms of heat transfer does the lid reduce? The lid reduces conduction and convection from the air on top actually touching the liquid. Question 1b, you're shown a picture of a patio gas heater and you're asked to explain why the designers have chosen to make the reflective hood of a shiny material as opposed to a darker matte material. And the answer is that the shiny material reflects the heat down onto the people below, so for its purpose to heat the patio, which is what you want, whereas a matte colour would absorb the heat and the lid would get very hot. Although it would also radiate the heat, it would also get the lid very hot and it would radiate upwards as well. Question 1c, you're asked to explain why on a Sankey diagram the input energy is equal to the output energy. That's because energy is not lost, it's always conserved. So you have total input energy always equals the total output energy, because energy cannot be destroyed. It's merely transferred from one form to another, and with a Sankey diagram it shows all the destinations of the energy, different bits of energy. Even if it's wasted, it's shown up on the Sankey diagram. Question 1d, you're asked to draw a Sankey diagram for the operation of the patio heater. You're told earlier in the question that 10% of the energy is released as light, and so your energy should show 100% of it going in, 10% going to light, or 10% or less, and 90% going to heat energy.